Hey everyone, so in this video we're just going to talk about doing a hypothesis test to see whether two groups have a different mean. And so remember we've kind of set this up so that gender is a predictor in a model with the course score as the response. And so we had this 0.1415, which was our estimate for the difference in means between the two groups, the mean for the males minus the mean for the females. And so because this slope is representing this difference in means between the two groups, it then makes sense that a test to see whether the two means are different would just be a test about whether the true slope is equal to 0 or different than 0. If it's equal to 0, then that means that the mean scores for males and females are not different. So if that's 0, then that means that there's no difference in the mean scores. If it's not equal to 0, then that's going to be the hypothesis that the mean scores for males and females are different. And so just to make that even a little bit more explicit, the reason that we're testing this beta 1 is because beta 1, like we talked about in the interpretation section, represents the difference in the average scores. In particular, it's the average male score minus the average female score. So if it's equal to 0, then that means that there's no difference between the groups, because that difference is going to be 0. And if it's different from 0, then that means that there is a difference in the average score between our two groups. In this case, group is gender. And so the assumptions for this test are kind of similar to the assumptions that we had for regression with a quantitative predictor. The assumptions are going to be constant variance, large sample size, or no extreme skewness, and outliers of the response for each group, and then independence of observations within and across groups. And so I accidentally included this and had already posted it, so it was too late to change. But that's just our code that we don't really care. Can't ignore that. I'll just write oops. And you could learn R in a different stats class. So to assess this constant variance condition, we're going to compare these side-by-side box plots and see if it looks like the two groups have about an equal spread. In this case, it looks like they do. And so constant variance, we're assessing, do the box plots look like they have equal spread? In this case, yes. It might be helpful just to draw an example of a violation. So what would box plots look like if they didn't have equal spread? And so like an extreme case would be one group would have really, really tiny spread. The other group would have like a really, really large spread. The other two conditions are pretty similar to the ones we've already discussed when we had a quantitative predictor. The sample size skewness condition, that's good because we have a large sample size and there's no extreme skewness or outliers. Our independence, we already discussed that as well. And so what's left is just kind of to go through the procedure of the test. And from here, it's the exact same as it was when we had a quantitative predictor. So our Tstat is the exact same thing. It's going to be the estimate for that slope, which in this case is the difference in means, minus 0, the null hypothesized value, divided by the standard error from the table. And so I'm just grabbing the estimate from the table. I'm grabbing the standard error from the table as well. And if you calculate that out, you'd get a T-stat of 2.784. Degrees of freedom are still the exact same because we still have an intercept and a slope in our model. And so there's still 461. We could still draw our T-curve like we're used to doing. Mark our observed T-stat of 2.784. And shade the tails that represent our p-value. Because remember, these are values that are seen as more in favor of the alternative, because that would mean that the slope estimate would be farther away from 0. If you use stat key, you would get a p-value of 0.0056. And then finally, we just want to write a conclusion in context of the problem. And this is also going to look super similar to stuff that we've done in the past. We want to start with our point estimate. So remember, our point estimate is 0.1415, but we want to say what that means in context of the problem. So I'm going to say we estimate that the mean course score for males is 0.1415 points higher than the mean course score for female professors. All right, so that's part one. This is our point estimate, but we're interpreting it in context of the problem. Part two, just like all of our other conclusions, we want to say how much evidence there is for the alternative hypothesis. In this case, our p-value is very small. And so I'm going to say there is convincing evidence that the mean course evaluation score is different for male and female professors. Then I'll give our T-stat, and I'll give our p-value. All right, so that kind of wraps up this hypothesis test for the difference in means between two groups. We'll wrap up this section with the next video talking about a confidence interval for the difference in means. As always, let me know if you have any questions about anything.